Hello and welcome to the inaugural episode of Perspectives from Lifecycle Insights. I'm Chad Jackson, your host, and today we're going to be talking about CAD consolidation. Now, there's been a trend towards CAD diversification for many, many years, but there have been a lot of new capabilities for CAD applications that are starting to reverse that trend. So before we get into those capabilities, though, let's talk a little bit about how we got here in the first place. Now, back in the spring of this year, 2013, I conducted a research study that looked at this exact issue. It was called the 3D Collaboration Interoperability Study. We received over 840 respondents to the survey overall, and it looked at exactly what was driving these sort of interoperability issues. Part of that study took a hard look at quantifying exactly what the problems or issues were that arose from interoperability problems. What we found was that 49% of engineers spent at least 4 hours a week fixing broken geometry. Now, that in turn turned into other issues. 50% of those engineers also said that they worked late or on the weekends. 32% of the respondents cited that they missed deadlines because of the interoperability issues, and 29% stated that they ordered incorrect parts because of interoperability issues. Now, obviously, there's a lot of time that's been lost due to these issues, but let's talk next about how this has driven CAD diversification. So we've talked about some of the issues that crop up because of interoperability problems. Now, that design data itself comes from a lot of different sources. Obviously, it comes from suppliers, partners, and customers, but also it comes from a variety of other internal sources. And that is mainly driven through acquisitions. You know, today you see a lot of companies acquiring other companies, especially with the economic downturn. Now, what happens is as you have multiple engineering organizations from different acquisitions, the likelihood that they're using the same exact CAD application is fairly small. So what you end up having is multiple teams working in different CAD applications. And suddenly, as you would expect as part of an acquisition and a merger, is those teams are now expected to work together seamlessly. You want to be able to reuse expertise, deliverables, parts across product lines. So suddenly you have design engineers exchanging design data back and forth between those teams. That design data is in different CAD formats. So first they try to use STEP and IGES formats, which are neutral formats, and they run into a lot of the issues that we cited before, spending at least 4 hours a week fixing that broken geometry. But fairly quickly after that, you end up acquiring those CAD applications within the teams so that you can work with that data, whether it's trying to interrogate it and take measurements, whether you need to make changes, whether you need to create other deliverables like drawings, so on and so forth. As a result, that's driven a lot of CAD diversification, and that's why you see numerous CAD applications in organizations today. Now, to try to drive things back towards CAD consolidation, there's basically three challenges you need to address. The first is cleanly translating models from all those other formats into a single CAD application. The second issue you need to take on is how do you either enable change or propagate change from those models, from those different CAD formats. And last but not least, it's always important to create deliverables. How do you enable associativity from the model to those drawings, manufacturing models, as well as assemblies? So that's the point, that's the purpose behind CAD consolidation. Those are the things you really need to get done. Let's talk next about the capabilities of CAD applications that have just emerged in the last few years. So let's delve a little deeper into each of these three issues. The first is, how do you get clean geometry translated from one CAD application to another? But before we talk about the capabilities, let's talk about the fundamental problem here. Different CAD applications use different geometry kernels. Those are kind of like the calculation engines that figure out the size, location, and shape of geometry. Now, when you move from one CAD application to another, you're going from one geometry kernel to another. And as a result, that breaks the geometry in the models that you're trying to get over. So what can be done in this case? Well, it's really interesting. A whole new class of applications emerged over the course of the last decade called 3D visualization. Those tools can natively open CAD models from a wide variety of formats. And what we've seen over the last 5 years is the incorporation or inclusion of that functionality into CAD applications themselves. Furthermore, direct modeling capabilities have come into play in a big way. Those are the capabilities that let you push, pull, and drag geometry without using features. But a subset of that capability is also fixing broken geometry. So if there are surfaces that need to be removed and replaced, you can do that very quickly and easily. So those are two capabilities that directly address how do you get clean geometry over from one CAD application to another. Now, the second issue is all about enabling and propagating change. Now, the reason why this is broken, and what the fundamental challenge is as you translate from one CAD application to another, the features, those parametric features that are used to generate the geometry in the first place, are actually stripped out of the model completely. Basically, all you get over is geometry. And that leaves you with no mechanism to drive change to that model. Also, when you translate or export a model out of a CAD application, the associativity from the original model to the exported geometry is now completely broken. So a change to the original model does not show up in the translated model. Obviously, that can be a problem, especially if you want to understand design changes that are being made in the supply chain. Now, the capabilities that are really addressing this issue are a couple of interesting ones. One is natively opening those models from different CAD applications. But also, direct modeling has a huge part to play here. Instead of using features as the mechanism to drive change in those models, now you can just push and pull and drag on that geometry instead. You don't need to bring the features along with you in any way, shape, or form. Furthermore, by opening native files, some CAD applications are able to maintain associativity to the original model back in the original CAD application. So that means when a modification is made in the original CAD application, those changes actually show up in a completely different CAD application. So it's very similar to modifying a part and seeing a change in a drawing, except it's part-to-part associativity in different CAD applications. The last thing to really take a look at is supporting associativity to deliverables. The fundamental problem here is that when you translate models from one CAD application to another, it breaks that associativity, as we've discussed. Now, of course, you can create drawings, manufacturing models, and you can build assemblies out of those parts. However, again, when the original is changed, that doesn't propagate over into the translated model. So all those deliverables based on that translated model are no longer accurate. They're actually out of date. Now, the critical thing here is that, again, if you're doing a native translation or opening a native part directly, then that associative link is maintained. That means that any other deliverables based on that translated part will get updated automatically. So if you do make a modification in the original CAD application, that updates in the other CAD application, the drawing, the assembly, the manufacturing model are all updated as well. Those are the three categories that are critical to take on if you want to look at CAD consolidation. So that's it for this episode of Perspectives from Lifecycle Insights. Today we've been talking about CAD diversification and CAD consolidation. For so many years, people have just assumed that CAD diversification is just a cost of doing business in today's engineering environment. But after years of new capabilities, actually it's very feasible to consolidate CAD again. If you want more detail on this topic, you can always read my new ebook, CAD Consolidation, Rewriting the Rules of Design Exchange. Thanks for your time.